asked us to evaluate the following integral from 0 to 5 x dx over square root of 1 minus 2x squared. And I rewrote the integral into 1 minus 2x squared to the negative 1/2 times x dx. And then I used the u substitution rule. So u would be 1 minus 2x squared, and du over dx equals negative 4x. So that would mean du equals negative 4x times dx. So putting the u rule into the integral, it would be u to the negative 1/2, and if there would be, so the negative 1/4 comes from if there was a negative 4 here, the negative 1/4 would cancel out with the negative 4. So that's where this du comes from. So negative 1/4 times 2u, u. So then we find the antiderivative of u, which is 2u to the 1/2. And then we multiply negative 1/4 with the 2, which is negative 1/2 u to the negative 1/2. And then we substitute 5 and 0 for u. Wait, I feel like I'm doing this wrong. Oh, I did something wrong. I'm sorry.
Yeah, what's wrong?
I was supposed to put 1 minus 2x for u, and I forgot to do that.
Right. Great.
Yeah,
Great. But you use a u substitution. Sometimes people change the limits. People use a u, so if x equals 0, u will be 1. If x equals to 5, you substitute into this substitution. You could change the limits. Or you have to change it back, 1 minus 2x squared for u.
Yeah, okay.
Yeah, but it's good. It's good, you see your own mistakes. All right, so can we fix right here, right now? I think you can fix it right now.
Okay, so it would be negative 1/2 times 1 minus.
Yeah, that would be tedious, right? At this moment, maybe you want to change you maybe want to change the limits, the lower limit and the upper limit. Do you see that? You see, your x value goes from 0 to 5, right? And then your u equals to this. So when x equals 0, you substitute into this equation. U will be 1 minus 0, u will be 1. So if you want to do that, you change this to 0 to be 1. Then when x equals to 5, so 5 squared 25, 2 times 25, 50. 1 minus 50 will be negative 49, right? It's a little bit difficult. You see, this goes from 1 to 49, negative 49. Okay, or you can just go back to change it to be 1 minus x squared. It's the same thing.
Okay.
Right, if you do that, what do you get? Oh, hold on. I guess you get imaginary numbers.
Wait, 1 minus.
Anyone else want to present after one finished?
So it would be -1/2 times 1/3 which would be -1/6.
Okay, all right. It's always great, we're able to see our own mistake. Okay, great. Thank you.
Thank you.
Thank you, Wang. Anyone else like to present the rest of the questions? Or anyone has any questions regarding homework? I see someone send me a message over the homework. Chloe, let's see, is Chloe here? No, it's not here. Okay, anyone has any questions? $42. Okay, one is asking for 42. Let me bring up the review sheet. Okay, 42 when we need to find a derivative, right? We want to use the first theorem of fundamental calculus. Let me see, let me write here. Let's review for the first part of the fundamental theorem of calculus. Oops. we said f of x equals to, let me use S. Let me use big letter S to represent the integration sign, right? Then the lower limit is a constant number. It's a number. The upper limit is some function. Let's see, some function that's called g of x. Oops. A g of x. Then we have some integrand, right? Some integrand, let's call it h of t. Then dt. So integration, lower limit, why is z here? Lower limit is a, it's some number. But this number is in the, let's write here too. So the certain conditions has to be satisfied. So a, the lower limit, a is in the domain of h. So h is integrand. So here, let's break up those. So integration, the lower limit is a number, this a. So this a has to be in the domain of h. It's kind of confusing. We have two variables to deal with. We have x, we have t, dt. We're treating t as a dummy variable at this moment. It doesn't really do much, but just to differentiate from x. So the upper limit is a function. It's a function of x. So I use g of x to represent. Then the integrand is some other function with a t. Like in this case, right? Let's write our case out. So in our case for 42, we don't have the lower limit, right? I mean, the lower limit is not a number. So we're going to deal with that later. So what's our h of t? Well, h of t is 1 over square root of 1 minus t, right? Then dt. So if the lower limit number is in the domain of h of t, and this one, so what's the derivative of f? What's f prime? So f prime of x then equals to the integrand, which f of t, which needs to be h of x. Then we multiply by g prime of x. Let's make sense of this. So if the condition, if f is the integration from a up to an x, a function of x, then the integrand is in terms of t dt, and the lower number is in the domain of h. Then derivative of f. Think about this. Think about it. We're taking derivative on both sides, right? So we have d dx. So so take derivative on both sides. Same thing on this side. So take a derivative on both sides. And remember, derivative and the integration, differentiation and integration are opposite operations, right? Like a plus minus, as if we didn't do anything. So the only thing is to check to see the lower number is in the domain of h. And when we do f prime of x, we have to multiply by the derivative of the upper limit, so g prime of x. So let's check ours. Ours, we do not have a number. So what do? So we need to say, okay, let some number in between of those two. So let's say sine x is less than or equal to doesn't really matter, right? So we know the equal sign. We know integration at one point equals to 0. So let's just take any number in between of those two functions, sine and cosine. So then we split this into two integrations. We split from sine x up to a, then plus from a up to cosine x. So we have to flip the first one because a is on top, is the upper limit, which is a flip, right? When we flip the upper limit and lower limit, they introduce a negative sign. Then the rest, we just follow the first part of fundamental theorem of calculus. Okay, does that answer your question, Vaughn? There are some recordings. There's some recordings, and yeah, someone has showed this kind of problem. Okay, anyone else has any questions? Okay, Andrew is saying, can we take the final exam at a later time? Let's see. The department is scheduled for, let me see my notes, for 17th. So the latest day we can do is on 17th. On 17th, the time is weird. The time is from 6:45 in the morning up to 8:45. So if you all agree, we can do that. We can follow the departmental schedule. So it's 17, which is 3 days later. It's on 17th, 6:45 to 8:45. Yeah, I have some other students that take the exam on 17th also. Oh, 14 is better? Yeah, okay, we agreed on 14, right? Oh, Andrews mean not 7:10 in the morning, I see. So what time? What time is better for everyone? I mean, I can do any time. Really depends on the rest of you. I can do any time, just not at night. Or evening work. So evening, every Monday evening, I have a meeting, 8 o'clock, I have a meeting. So can I be in the evening? I'm sorry. Because I know some other students that they have to go to work. This kind of difficult, because right now there are only 15 of us. You know what? Let me. So how do I do that? Because right now there's only 15, so I think the rest of them thinks it's on 14. If I change time, Or Tanzania asking when is the final? The final will be on 14th, which is the day. Right now we're talking about the time. Okay, the only thing I am afraid of is someone may have to go to work. Because for people registered for the early class, some of them have jobs later on. Yeah, hopefully comes in more people because I have, let me see how many we have. We have how many students? 42 students. So let's see. So Angel is saying, I'm okay with any time as long as it's not 7 in the morning. Oh, Stanley has a final 9 to 11. You see, that's the finals week. Right, so that's a problem already. Right, right. So now, okay, we can decide the date. So 14th or 17th? If it's the 14th, so 7:10 works for everyone, isn't it? Because last time when we talked about the 7:10, okay, so you, oh, Malika time from 11 to 6. Okay. Okay, so guys, do you see in the chat? No, we have people 9 to 11 final, 12 to 6 job. Okay, that means we cannot change. We can only change the date. We can do 14th or 17th. I think most of us agree on 14th, right? Anybody don't like to do on 14th? Okay, if 14th works for everybody, I guess we have to stay with the time, 7:10 to 9. Because if there's only one confliction, we cannot do it. Okay, I think you guys can do it. You know why? You have endured the whole semester. This is just the last class. This is the last time we'll have to meet online. So that day, I'm gonna go online a little early, all right? So to remember, you have to have your student ID or any picture ID with you, because some of you, I know you don't have a picture ID, student ID. Make sure you have a picture ID with you. Okay, and some of you haven't got a full credits for presentation yet. And your homework, I haven't, right, I have been checking your homework, but you still have time to do it. Yeah, there's 1 week, all right. All right, let's go back to the review sheet. So anybody like to present any other homework, any question from the review sheet? I think we're left with a couple of them. Or anybody has any questions on the review sheet? Okay, Jason want to do 37. Let me make you presenter. Oh, Amir, you have a question? Let me see. 5 minutes ago. I'm sorry. I missed it. Let me just go through this. For the final, we arrive here 14th, take picture of our work for each problem, a separate image with student identification on top, and we might need to use a camera, right? Yes, just like your homework, right? Oh, Amir, right. Do you have any problem to do that? Oh, okay, that's great, right. So, right, we need, right, so you need, yeah, hopefully in the future, the system become better and better. Right now, right, for sending that, you have to take pictures and send to me. But also, let me see this week, if I could work on maybe, yeah, okay, if there's a change, there's a more convenient way to do that, I'll let you know. But yes, okay, you have to, right, because Hunter checks the student ID. So once you finish your exam, right, you put your ID on top, you take a picture of each page with your ID, a picture ID, to verify you did the work. Then you take pictures, you send to me through the Blackboard. I think that's a submission. I will open the final exam on 14th. Okay, let me see if there's any other question. Yeah, Angel, sorry. It looks like we have to do on 7:10, start on 7:10. It's just last time, all right? Okay, I think I answered everyone's question. Okay, Jason, you can show us 37.
Can you make me presenter?
That's right. Okay, now you are.
So we are trying to find the rate of change of the radius of a cone when the radius of the surface of the water is 2 feet. So it's given that the radius of the cone is 5 feet and the height of the cone is 15 feet, and then the rate of change of the volume of the cone is the water filling the cone is 12 feet cubes per second, and we're trying to find the rate of change of the radius when the rate of change of the radius when the radius of the surface is 2 feet. So first, we have to find the height because uh, we already have the radius here. So to find the height, we know that these two triangles are similar triangles. So we could set an equation r over h equals 5 over h, these two variables. 5 over 15. So r over h is 1/3, and then to find the height, you just cross multiply. So h equals 3r. So now we have h, so we could plug in h to the equation of a cone. So right here, I plug in 3r, and then so the 3 cancels out, so it's 3 cubed pi. So now we find the v prime, which is the rate of change of the radius of the surface of the water when the radius of the surface is 2 feet. So now we could plug in. Well, we find the v prime. So v prime. To find that, we use for the product rule. So v prime, the prime of pi is 0. So this cancels out, plus pi, and then we use the the exponent rule, I think. So 3 minus 1 is 2, and then the derivative of r, which is dr over dt. And then, so I plugged in v prime, which is 12, equals pi cubed 2 squared r prime. So that equals r cubed equals, r squared equals 4. Multiplied by 3 is 12. 12 pi r prime equals 12. And then I divide both sides by r pi. So I get 1 over pi equals r prime. That's the answer.
Okay. So your picture confused me. You said, right, we're using the similar triangles. So 2 triangles. Which 2 triangles? The one.
These two. The big one, which is the cone, and then the small one, which is the water that's filling the cone.
Okay, if you use that two, right, the size, the top wouldn't be 5, because the 5 is the radius. So what number would you use?
R2.
What do you mean? No, let's see, the similar triangles. So you use the 5 over 15, right?
Yeah.
So 15, you see 15 is not even in these 2 triangles. Can you fix that?
15 is the height.
15 is the height. So can you redraw your 2 similar triangles? Oh, okay. Anyway, you want to use the height. Okay, that's okay. The height of those 2 triangles are proportional also. But if you use a 5, you see 5 is not one side of this triangle.
I mean these 2 triangles.
Right. Right. Yes. Yes. Okay. My second question is, let's see, on the left-hand side, the first equal sign, second equal sign, third equal sign. From the third equal sign to the fourth equal sign, what did you do here?
From here to here?
From the third equal sign equation, from the third equation to fourth equation.
Third equation?
Right, the third equation. V prime equals to the pi r cube. No, V, right? V equals
Yeah, cross
pi
it
r cube.
out.
Right. Oh, okay. So you take a derivative. Can you tell me
Yeah.
how do you take the derivative?
Using the product rule?
Oh, okay. Do you need to use product rule here? Do you have 2 variables?
Oh, no, you don't.
Right.
I thought, yeah.
Oh, now I understand what you did. Right.
So I use pi instead of 0.
That's right. You said the derivative of pi is 0. There's no need, because the pi is called a scalar. When we take derivative, the scalar come out of the differentiation. We just differentiate r cube. just leave pi, just inherit pi, rewrite pi. 3r squared r prime times pi. It's called scalar. Okay, all right. But there's nothing wrong. Just one step more. There's no need to use product rule for this. So we just keep pi because it's a scalar. Okay, all right. Great. Thank you, Jason.
Thank you.
All right. Anybody else like to try any questions? Or anyone has any questions on for the review sheet? Okay, so you're telling me you are all ready for the final exam, right? Because today is our first class, is our last class. So 10th, we don't have class anymore. So the next time I see you will be 14th. Okay, one wants to show 35. Yeah, go ahead. Let me.
Okay, so this is question 21, and we're trying to find the area, the volume around x-axis, and the volume around the y-axis. So we have y equals 2x squared minus 1, and I graphed it right here. Then I equal 2x squared minus 1 equal to 0 to find the x values, which is plus minus square root of 1/2. So that would be the values for the area, the integral from -1 square root of 1/2 to square root of 1/2. And I subtracted 0 minus 2x squared minus 1. And so I found the antiderivative of negative 2x squared plus 1, which is negative 2/3 x to the third power minus x. let me start over at the area. Area equals -2/3 x to the third plus x, and then I substituted square root of 1/2 and negative square root of 1/2 for the x values, and I simplified that to get square root of 2/3 minus negative square root of 2/3, and the area would be 2 square root of 2/3. So for the volume about x-axis, I used the same x values, negative square root of 1/2 and square root of 1/2. And the radius would be -0 and 0 squared minus 2x squared minus 1 squared. And the radius would be -4x to the fourth plus 4x squared minus 1 to find and then we found the antiderivative, which is -4/5 x to the fifth plus 4/3 x to the third minus x. Then we substitute the x values, square root of 1/2 and negative square root of 1/2 to get a volume of -8 square root of 2 over 15 pi. And for the last part, volume about y-axis, we took y equals 2x squared minus 1 and isolated to get the x equals square root of y plus 1/2 because the radius would be horizontal now. So then I took square root of y plus 1/2 and equaled it to 0 to get the y values of -1 and 1. So since I had the integral from 0 to 1, I used 2 pi r squared since it's multiplying by 2. So then I found the antiderivative of y plus 1. Wait, no. So then I got 2 pi r squared, which is square root of y plus 1/2 squared, which would be y plus 1/2. Then I found the antiderivative, which is 1/2 times half y squared plus 1. Then I substitute the y values 1 and 0 for y, and I got 2 pi times 3/4, which is a volume of 3 pi over 2.
Anyone has any questions? Okay, let me ask you some questions.
Yeah.
So let's see, when we revolve with x-axis, right? So get this picture. So what do you mean on the two sides? So can you show us the radius in the picture?
Oh, you want me to show you the radius?
Right, can you draw it? You have pi r squared, but explain to us why the first r is 0, the second r is 2x squared minus 1.
Wait, can you repeat your question?
Okay. Can you explain to us why, so inside the integration sign, the integrand, the pi, if you want to do pi r squared minus 2x squared minus 1 squared, you need parentheses. I won't be able to write on your paper. Or you can leave the pi outside the integration. Right, put your pointer on the pi, on pi.
Pi? What?
Yeah, right. You see here, this pi, you have pi times 0 square, right?
Yes.
So, but you don't have pi times 2x squared minus 1 squared.
You mean this?
Yeah. Well, your pi apply to both of them. You see a pi here, right? Right. Yes. Put the parentheses around. Right. Your pi applies to both. Okay. Now, so one radius is 0. One radius is 2x squared minus 1. Right. Just explain to us why one radius is 0, the other radius is 2x squared minus 1. You can draw picture. You can draw on your graph.
So it would be, the radius is this way.
Right. Right.
Yeah. Vertical instead.
That's right. Basically the y value of the second function. Okay, now come down to here. Your volume equals a negative value. So how do you adjust that?
Are you saying it's not a negative value?
A negative value is pure mathematics, right? It could be negative value, right? But I was asking you, how do you justify that? Why it's negative value?
Oh, because the volume is underneath x equals 0, so it has to be negative.
Because you use 0 minus x squared minus 1 squared. But sometimes, right, if we want to think of the volume negative, does not make sense. We could just flip those two r's. Okay, good. Okay, third one. Can you show us your radius when we rotate with y-axis?
Turns like that.
Great. Yeah. Okay. Let's see. 2 pi r squared. Oh, right. I have a question on the, let's see, the first equation, second equation. The second equation, Okay, the second equation, all right, you need parentheses also, and also explain to us why is 2 pi instead of pi r squared.
Oh, because I used the values from 0 to 1 instead of -1 to 1. So if we're just using half a part of the volume, we had to multiply by 2 to get the full volume.
Okay, let me do this. Yeah, you said the radius is this x value, right?
Yes.
The radius is this x value. So when we rotate this piece, what kind of 3D picture you can imagine, 3D object you can imagine?
This
Yeah, this kind, right? But we don't have to draw this high, because we don't have this high. You could just draw the circle down. Really, we get this whole thing. We get the above x-axis as well. when we rotate this piece, right? When we rotate this piece with y-axis, let's see this one. That's why the second one, right? Second one, I was a little confused about your picture on the two sides. Imagine when we rotate this piece with x-axis, we only get this. We don't get the two sides. You draw the bigger part on the left side, on the right hand side. We only get the middle part.
I mean this?
The second one. The second, when we rotate with x-axis.
Oh, this?
Yeah. You see the 3D picture? We don't get the left part, the right part, but only the middle part.
Oh, okay, okay.
So
it's just this part right here.
just part, right? So similarly for this one, when we rotate with the y-axis, we only get the bottom solid. We don't get the top empty. Everything's under x-axis. Yes. Only the lower part, the solid ones. So do you think we need to multiply by 2?
I guess not.
No, we don't need to multiply by 2, right? Because when we rotate, there's like an overlapping part. We still get to the bottom, this bottom. So all we have to do is to figure out the radius. The radius is x value, as you figure out. So we don't need this 2. Just pi r squared.
So it would just be 3/4 pi.
Right.
Okay.
Does that make sense to you?
Yeah, okay.
Okay, we only get to the bottom solid, and it's like a ball under x-axis. Okay, good job. All right.
Thank you.
Thank you. Okay, anybody else like to show any work? It's your last class for you to earn some presentation credits. Okay, or anyone has any question? Mia, for the final, what people are going first and last? What is the order for presentation? No, the final has no presentation. The final presentation will be my choosing. Like as I said before, not everybody have a good grades on presentation. So some people might have some difficulty to present. Maybe they have to go to their jobs or something else. If they do very well on the final, I'll ask them to present to me, because as long as they show the understanding, I can be more generous on the presentation credits. But for some of you already get full credits on presentation, you don't need to present to me anymore. All you have to do is to do well on the final. We don't have a class anymore. Today is our last class. Yes, it's an open book. You can use your notes. Number of questions are written or something else. What do you mean by that, Amir? Basically, okay, the questions were open for you on that day, right? On Blackboard. The questions were open for you on Blackboard. Oh, let me show you. Let me share with you. Okay, I don't want to show you the grades. All right, you see here, it said the final exam submission. Right now, you don't see anything, but this will open for you on 14th. So on 14th, you will see this, the final exam as a PDF file. So you open it, the exam will show you, will pop up. So you don't have to copy the question, all right? Just write down the number. Just write down your solution followed by the number of the question. So right, you can consult with your notebook, your homework, your textbook. But you cannot consult with another person, all right? You can consult with your own notes. So only write question numbers to save time. Make sure you show your steps to earn full credits. Because sometimes you may not get the right answer, but you have the other steps are right. So I'm looking for the right steps to give you credits, even the answer, even your solution is not totally right. Right, so put your ID on top of each page of your final exam. Yeah, sign your name on the bottom of each page. So submit through CUNY Blackboard. So once this is open, once this submission open, they give you opportunity to submit your solutions, your final exam solutions. Let me see questions. There's no multiple choice question. Right, you can use notes. Is a presentation thing after our test or on a separate date? No, some people may not have a chance to present to me anymore. It all depends on the final. If you do very well on the final, you don't get full credits on the presentation, I may invite you to present to me. But for students, not doing well on the final, there's no more opportunity to present. Noella is asking, so we stay in class? Yes, you stay in your place. All right, with camera on. Yes. Yes. So the final is on 14th, 7:10 to 9. Through the hours you're doing your final, you have to show me your ID. First, show me your ID to identify you are the person who takes the exam. Then send me your exam paper with your ID on, with your ID on top of your exam. Right, you have to stay camera on for the period of exam. There's no multiple choice. Every question you have to show your steps. Can we use graphical calculator for some questions? Actually, for this course, you're not supposed to use your calculator. But since this is an open book, you could use your calculator, but for your calculator, use your calculator to confirm your answer. Because there is one question to ask you to graph rational functions, right? You have to show how do you get a y-intercept, how do you get domain, the range, the x-intercept. You have to show these steps, the vertical asymptotes, horizontal asymptotes. If you only give me answer, which means if you only use your graphing calculator to calculate, then to show to show this, but you don't show me steps. You only get, part of the credits for graphing. You don't get, if you don't show me steps how to get them, you won't get full credit. Ruli is asking, there are other professors who are allowing students to take an exam at whatever time throughout the day, as long as it's submitted before the end of the day. Would that be better so we can choose what time to take it on that day based on what? The problem is this, Ruli. For some classes, they're able to do this. Like I have some other classes, I'm able to do that. But for this course, I'm not able to do that. All right. So let's just do in one shot because I won't be able to practice you any other time. But anyway, for some students, if you have special situation, you can write to a testing center. So they will practice you, all right, in another time. But if you have, I think I do have one student, right? So let me know if you have some special situation. You read, I don't have a working graphic calculator. You're not supposed to use a graphic calculator anyway, you read that. So if you don't have one, don't worry about it. You read that, no, you cannot use your computer. Your computer has to be, your computer only for you to look to for the exam, all right? You cannot use your computer to graph. So during the final exam, right, you cannot use your computer. You cannot use your cell phone. You cannot use your computer. Andrew is asking, the questions on the final exam are similar to the ones on the review sheet, right? Yes, yes, you're right. And me, I still do not understand the way the final is graded. Presentation is what percent out of 100, and the actual questions are added up to make a full score. All right, I probably confused you. All right, let's see this. I don't want to show you. Let me stop sharing this. So let me give you an example. So let me just go there. Okay. So some of you, like Amir, right? You get full credits on presentation. So you have no worry about presentation anymore. All you have to worry about is your homework and your final exam. Because I do not have your homework grades yet. And also nobody has a final exam grades. But not everyone gets full credits on presentation. Some people don't get anything on presentation. So for those students, I know this semester is super difficult for everyone. So I'm considering this bunch of students. They have difficulty to be in class. They have difficulty to present. So what I'm going to do is this. If they show me they understand the material, they do well on the final exam. And, but they do not have good presentation credits. So what I'm going to do, I'm going to invite these students to show me, all right? If they can show me they really understand everything, so I'm going to give these students, certain amount of presentation credits. So in that case, these students can have a better grade for only based on homework and final. And also, the homework part, I see a lot of you needs to, right, a lot of you, so the homework we'll do on the 14th also. If you want, I can give you a couple more days. Maybe the homework I can, let me see the due date of the homework for now. Oh, okay, December 20th, right? '20th, right? Okay, so on 20th, good. So you get a couple more days to do that. So right, so you right for on 20th, good. So right, so Amir, that's the answer for your question. I hope you're clear on that. For you personally, you don't have to worry about presentation because you already get full credits. For some students, already get full credits. You don't have to worry about that. Let me see. How many questions are there on the final? Let me check. I think let me see. Because it's an open book, so not this one. $18 questions. Each question is just one question, except the graphing. The graphing has 7 part of it, right? The total only 18 questions. It's, you know, it's not difficult at all. You know, if you can do the review sheet, this final exam will be super easy for you. It's super, because usually from 150 you get 20 to 21 questions, but because of the difficulty of this time, so it's only 18 questions, and the questions are kind of easier than some of the questions on the review sheet. Yes, the homework due on 20th. Right, it's on Newman. Remember, you don't have to do 100% right, all right? Homework is graded as complete as long as you do 75% right. And for the quiz also, you don't have to do 100% right. If you do 80% right, you get full credits. So don't stress out on those. Amir, you said that separate, you believe. What do you mean that separate? So the final, each question is just one question, except the grade, the graphing. Graphing, you have to show me those things. You have to show me the domain, the range of function, the asymptotes of the function. You know, you have to show me maybe the critical points, if there are any, the inflection points, if there are any. Then the last part is the graphing. Right, okay, Amir, you think Lumen problems are, some of them even more difficult? Forget about these difficult questions, okay? Again, you only have to, the homework part, you only have to do 75 or above. The quiz, you probably need to do 80, 90% right, all right? Don't focus on doing everything right. Focus on understanding the material. Okay, any other questions? All right, I think, I feel very confident for most of you because, for the work you showed me, you can do it. So, keep studying. You still have 1 week to prepare. During this week, if you have any problem, send me an email. All right, talk to me. And also if you have specific questions, you also can ask, what do you call it? The Docente Center, all right? We have tutors to help you. Okay, anybody has any other questions? If not, I'll see you on 14th. I'm going to send out an email to make sure everybody is good with this time. So on 14th, class time 7:10 to 9. I'll be online a little early in case you have any questions. I'll give you time to take pictures to send to me, all right? So don't stress out. So the whole purpose of everything is to make sure you understand the math material. That's it. That's it. All right, I have a good day, and I see you on 14th.